Assalamu alaikum and good morning everyone. Today the topic of the presentation is round robin CPU scheduling. First of all, let me introduce myself. I am Khadeeja Hussain, RC01 from BSCS 34A 5th semester, and this topic belongs to the course operating system. We have the table of the content where we will discuss a brief introduction about the topic, then what actually round robin scheduling is, moving on to its examples, then its specific characteristics which make it distinct from other scheduling schemes, then its disadvantages and advantages, and moving on to the simple questionnaire session. Now let's discuss what CPU scheduling is. So CPU scheduling is the process of determining which process will own CPU for execution while other process is on hold. Now let's move towards the main topic, which is round robin scheduling. So basically, round robin scheduling is a primitive process scheduling algorithm. Each process is provided a fixed time to execute. Once a process is executed for a given time period, it is preempted and other process executes for a given time period. Round robin scheduling is one of the oldest and the easiest preemptive scheduling algorithms, which are often used in interactive systems. Before moving forward, there are some important terms to know when talking about the round robin scheduling. First one is the time quantum and the second one is the ready queue. So basically, time quantum or the time slice is the period of time for which a process is allowed to run on a CPU. And the ready queue is the queue that consists of all those processes that are to be handled by the CPU in order. So now we have how processes move back and forth from or to ready queue and from ready queue to CPU. So these animations give a clear depiction of how the processes are moving from ready queue to CPU and from CPU to ready queue. So in basically in a round robin scheduling scheme, this context switches is happening all the time, where processes are moving from CPU to the ready queue and from the ready queue to the CPU. We have the example related to the round robin scheduling. Here we have process 1 with the arrival time 0 milliseconds, then process 2 with the arrival time of 10 milliseconds, then process 3 with the arrival time of 20 milliseconds, and lastly the P4 process with the arrival time 30 milliseconds. Each have a burst time, which for P1 it is 100 milliseconds, for P2 it's 40 milliseconds, for P3 it's 50 milliseconds, and for P4 it's 30 milliseconds. See how those processes P1, P2, P3 and P4 are handled by the CPU using round robin scheduling. Here we have a quantum of 30 milliseconds. Firstly, the ready queue has only one process called the P1. This process is directly assigned to the CPU and can take only up to 30 milliseconds of quantum completely. After 10 milliseconds, P2 arrives in the ready queue. And after another 10 milliseconds, P3 arrives in the ready queue, as P3 has a arrival time of 20 milliseconds. After 30 milliseconds, P1 starts its work and P4 arrives in the ready queue as its arrival time is 30 milliseconds. After the P1 has depleted its quantum, it switches in the ready state and is inserted at the end of the ready queue. But the process is not done yet, as that after that the P2 gets the CPU and uses up its whole quantum. Therefore, it reaches into the ready state and is inserted at the end of the ready queue. P3 runs for 30 milliseconds and still needs to run 20 milliseconds afterwards. P4 runs for 30 milliseconds and completes its task and terminates and is not sent back to the ready queue. P1 is the process 1 in the ready queue again and runs for 30 milliseconds on the CPU, but it still needs to run 40 milliseconds afterwards. The dispatcher sends P1 back to the ready queue. Shortly after that, P2 gets the chance to complete the task. The P2 do not needs the whole quantum of 30 milliseconds, but only 33% of it, namely 10% of it. Now P3 arrives and start working again. It also uses only two-thirds of its quantum and terminates. Now P1 is the only process in the ready queue. It gets the CPU directly and use up its whole quantum. After P1 is depleted its quantum, it is not primitive and sent back to the ready queue. Since no process is now waiting there, P1 converts 10 more milliseconds until the job is done, and this is how the round robin scheduling works. Let's see the turnaround time and the average waiting time of the processes. So here we have process 1, process 2, process 3 and process 4 and their arrival time and rust time respectively. The turnaround time is 220, 150, 160 and 90 respectively, and the waiting time is 120, 110, 110, 60 respectively. Their average turnaround time and average waiting time is calculated using the turnaround time and the waiting time divided by 4 each is equals to the average turnaround time is 115 milliseconds and the average waiting time is 100 milliseconds respectively. Let's move to another example of round robin scheduling. Suppose here we have 5 students. Each student have to do some work on the PC, but unfortunately there is only one PC. So the teacher assigns some time for each student to access the PC. Person 1 gets into the room, access the PC, do its work, and if its time quantum expires, it gets out of that room. And if its task is not completed, it gets back into the queue waiting for the PC to get free. While the P2 gets into the room, perform its task, and if its task is completed at that provided time quantum, it exits the room permanently and will not enter the queue afterwards. Same goes for P2, P3, P4 and P5. After they have all completed, they will leave the room permanently, but each task here for the persons or the students is assigned a specific time quantum which is same for every student in the queue. Now let's discuss some characteristics of round robin scheduling. So round robin scheduling is the oldest, fairest and the easiest algorithm. It is widely used in traditional OSs. It is a primitive scheduling algorithm. Now let's discuss how it is different from first come first serve and shortest job first scheduling schemes. So in first come first serve, which is better for the small burst time, and the SJF, which is better for the processes which come to the processor simultaneously, the round robin is better to adjust the average waiting time desired. Similarly, the first come first serve and the shortest job first are implemented to favor turnaround time, while round robin is implemented to favor the response time. It is usually a trade-off between it. Moving forward, we have the advantages and disadvantages of the round robin scheduling. Firstly, let's discuss the advantages of round robin scheduling. In it, every process gets an equal share of CPU. The round robin scheduling is cycling in nature. Context switching helps save context or the state of the primitive processes. Best performance in terms of average response time. Disadvantages are that no special priority is given to any process that comes into the queue. Higher context switching overhead due to the lower time quantum. Spends more time on context switching as continuously the processes are moving from ready queue to the CPU and from the CPU to the ready queue. Processes don't have priorities as each process is assigned a specific time quantum, and that time quantum is common for all the processes in the queue. Hope you enjoy the presentation and get a better insight of what actually round robin scheduling is. If you have any question, feel free to ask any, and thank you and Allah Hafiz.